What should be next point? Low power consumption, right? Right now, you are always expecting that your laptop battery should be like 6 hours, 7 hours, 8 hours backup, right?
Low costing.
Yes, low costing. Okay. And third thing
Battery
is
should be low, right?
Area should be
Hello?
low. Area should be
right.
minimized.
Area should be minimized, right? Means compact size, less area,
Compact size.
right? Basically, we are focusing on 3 points. In any electronic device, we are focusing on 3 points: fast speed, low power consumption, and less area. Right now, so definitely, if you are focusing on area, so definitely cost will be automatically minimized, right? If you will purchase like capacitor, inductor, and everything, and you will make a computer, so definitely its cost to become too much high, right? Too high. So our main motive is these three things. We are always focusing on these three things: fast speed, low power consumption, and less area. And in any electronics research department, basically we are focusing on three parts. Means simply you can say that VLSI is totally R&D department, R&D domain, research and development domain. And you know that electronics is only research branch, right? You can't say that someone is working like a simple task electronics. Sometimes just taking an example, do you know some mobile assembling company are there, not mobile manufacturing. We are telling that mobile manufacturing company, but this is not mobile manufacturing, this is mobile assembling company. Like we have already motherboard, microphone, everything, just we have to connect to each other. Okay, so it's not the work of electronics engineer. This work can do who 12th pass candidate also, right now. But if you are telling that electronics engineer, what is the work of electronics engineer? So in totally electronics engineer means you have studied something electronics and you can utilize your concept there. It's called electronics engineer. You can do some changes, it means engineer. Sometimes no, like some people are telling that a technician has good knowledge compared to an engineer. You have listened many times,
Yes.
right?
Yes.
But it's not good. You can answer them that a technician is know only particular things, right? If they know that you have to use this resistance, suppose I am telling you your device has got like default sometimes. Suppose there is your device, your mobile or any TV, something. So there is resistance. How much resistance? 220 ohms resistance. Okay guys, there is 220 ohms resistance and this resistance has got burned. So a technician will what do? They can only search 220 ohm resistance.
Right.
If there is not available 220 ohms resistance, then what they can do? Nothing. They will search only this particular resistance. But as an engineer, what will you do?
We can make the 220 ohm resistance with some other value resistances.
Right. You can suppose you have 440 ohms two resistance, so you can make it as a parallel. Right now,
Right.
two 440 ohms resistance, you can make it parallel. Means you can think something. You can think that suppose this is the device already mentioned here. Okay, so what we can change there, so we we can improve the functionality of this device, right? What improvement we can make in this device? What can you change the how can you change the power consumption? Is there any way the device will work same like this, but their power consumption should be less? We can search this way. This is called as engineer, right? Right, guys?
Right, sir.
Yes.
This statement you should never tell that a technician knows better than an engineer. They can't do this. Okay? They can repeat same task only. Yeah. So now coming on the our topic. So less area. Okay? These are our motives. So what we have started here, instead of solid state devices, we have started from where? Cell designing. Everyone knows cell designing. What is cell designing? You don't know? Okay, so just let me explain. Cell design means sometimes we are designing something by using MOS. We came into the MOS, like NMOS, PMOS, CMOS, right? We are designing something by using MOSFET. So this is called as device, cell designing. But cell designing was a very difficult task, because if you are designing a simple full adder, so you can, do you know how to design NAND gate, NOR gate by using CMOS? Everyone knows,
Yes. Yes.
right? There is requirement of multiple MOSFETs, and you can think that a simple gates you are designing, so there is a little bit difficult, right? But suppose I am telling you just design a XOR gate or NAND gate you have designed, and by using NAND gate just I am telling you design a full adder, so it will be very difficult. Suppose I am telling you like design a 32-bit adder. So adder is a very basic part. So in industry we can't do like this. It will become very difficult part. So what we have done, now we came into the coding part. Here came what? Verilog HDL. Verilog. So Verilog means VHDL, Verilog, anything, hardware description language. It is the hardware description language. Okay, hardware description. What is meaning of hardware description language? Hardware description language means you can describe the hardware. By using this language you can describe the hardware, like same like you are describing software by using Java, .NET, C, C++, right? By using this language you are describing your hardware, right? So same, by using Verilog we can describe the hardware. Okay guys, so there are 4 ways to describe the hardware. Which 4 ways are there? 4 types of modeling. First is what? Gate level modeling. Not gate level, just we are explaining you first of all 3 types of modeling, whatever you have studied in your college, right? 3 types of modeling. Can you tell me what 3 types of modeling are there? Structural modeling, data flow modeling,
Data.
and behavior modeling.
Yeah.
Okay, these 3 types of modeling you have studied in your college. But the data structured modeling divided into 2 parts. Structural modeling divided into 2 parts. Which 2 parts? One is gate level modeling and another is what? Switch level modeling. Okay guys, one is gate level modeling and another is switch level modeling. So why it's called as structural modeling? Structural modeling is why called structural modeling. Basically, if you are designing by using these types of modeling, so you have to know the structure of the circuit. Any systems if you want to design, so you have to know the structure of that system. Getting my point? Suppose I am telling you, you have to design 4 bits of adder. So what is the structure of 4-bit adder? What is the structure of 4-bit adder? You have required here. Just I am telling you, like 4 full adder or 1 full adder and 3 half adder, right? Right guys? Everyone remember this point? Just let me show you the circuit. See here, 4-bit adder. Just like this, right? This is the 4-bit adder, and it's not sufficient. Basically, you have to know the half adder circuit. Here, full adder circuit, how it's look like, right guys? It's only block diagram, which it's very complex. It will become a circuit. Like here, half adder, it means 1 XOR gate and 1 AND gate, right now? Right guys? Please try to respond.
Yes, sir.
Yeah. So you have required these things, right now, for 4-bit. Means in simple way you can say that in a structure modeling we have to know the structure of the circuit, so we can design by using structure modeling. Okay. So here 2 types of structure modeling. One is switch level modeling and another is gate level modeling. So what is happening in gate level modeling? You have to know the structure in the form of logic gates, and in same by using switch level modeling you have to know the structure by using what? Switch. Switch means same MOSFET, MOS and MOS PMOS. So in this form you have to know the circuit. Another is data flow modeling. In data flow modeling what we are doing, just by using operator you can do something. By using operators you can do something, like same as you can say here operators is plus operator. Simple, you can do A plus P. This is very simple, right? Right guys?
Yes.
But here you have to use operators. Okay. Now you come to the behavior modeling. In behavior what we can do, in behavior modeling we have to know the behavior of the circuit. Like just you are designing a mux multiplexer. Okay. So what is the behavior of the multiplexer? Like 2:1 multiplexer, what is the behavior of the multiplexer?
Many to one.
Many to 1, right? And here we can say that if select line value is 0, so this line will come to the output.
Out.
If this line is 1, select line is 1, so this line will come to the output. So this is the behavior of the mux, right? Even we don't know that what operators we have required, what circuit for the mux, we don't know. But by using by behavior only you can design by using behavior modeling. Okay guys? Another example, just we are taking the counter. Okay, suppose mod 10 counter is counting from 0 to 9, so you don't have to know the circuit. What is the circuit of the mod 10 counter? What you have required here? Only what is the behavior of mod 10 counter. So behavior is count from 0 to 9, right? We have to know this. So nowadays in every industry there is used of behavior modeling, and sometimes mix up of data flow and behavior modeling. No one is using gate level and switch level modeling. Got it? Everyone understood? Yes. So now come to the same gate level modeling. How will you design by using gate level modeling? The font size is correct, or you should increase? Just let me increase this. Now it's okay, font size. Now come to the part of gate level modeling. Okay. Already explained you that gate level modeling is a structural modeling. It is a structural modeling, and we have to know the structure of the circuit. This is a structural modeling, and we have to know a structure of the circuit. You have to know a structure of the circuit. Structure of the circuit. Gate form. How? In gate form. Okay. Now there is some predefined primitives. What is predefined primitives here? And, or, not, NAND, NOR, XOR, XNOR, and buff. This all. Okay. These all are predefined in our compiler, in our tools. These all are predefined things. Okay, guys? Understood? So by using these predefined primitives, we can design our circuit. Just taking an example, not an example, just a structure of the gate level. You know, like for every coding language there is some defined structure, right? Everyone knows C language, basics of C, if you know. So there is some predefined structure. Some lines are repeatedly always, like hash include, right? Studio.h, right? Int main, curly braces open, curly braces close. Here we are defining some variables and writing the logic. So these are the predefined
Sir,
structure
cannot
for the
understand this.
do you know C language?
No, sir.
Okay, you don't know. Just I am telling you, there is some structure. If you are writing any language, so there is some fixed structure. So like I have given you example of C language. If you are writing any codes in C language, so you have to write this line compulsorily, right? Okay. Now understood? So same here, just I am taking you example for the Verilog. In Verilog also there is some defined structure, which is you have to write module. Here we have to select module name. Okay. And here we have to do the port list. Here semicolon, and here should be end module. End module. So this is the structure, and here you have to define the direction. This is the comment line, direction of the signal. Okay, and now instantiate the primitives. Okay guys, now understood this point? Anyone has any question here?
Sir, cannot getting this
Sorry, who is
module.
this? Who is this?
Aditi.
Aditi. Aditi, see here. Basically, this is the structure of our coding. This structure you have to follow every time. Just I am taking you one another example, so you will get. Okay. Suppose you have to write the code for the half header. Everyone knows the circuit of half header.
Yes, sir.
Everyone knows. Okay. So you have to write module. Module is a keyword. Okay. Again, you have to give here module name.
Half
What
header.
will be the module name?
Half header.
Half header. You can take anything in module name. So just we are giving module name half header. Half. And just remember one thing. You can't give a space in module name. You can't give a space in module name. So instead of a space, we can use underscore. Half header. Got it? Now, here curly brace, sorry, parenthesis open and close, and here we have to mention what? Port list. Can you tell me what is the port list in a half header?
Port list means
Port list means signal name. What all
Sam and carry.
Some carry and two inputs also,
Yeah.
Yes.
right? So just you have to give the name for two inputs, A comma B comma
Some comma carry.
Carry.
So this is the port list. Like just see here the example. Suppose this is the half headers IC. What you are making here? Making here a chip. Chip means just like a IC. Everyone has seen the IC,
Yes.
right? So IC looks like this. Okay. There is two pins here input and two pins are output. Right now, everyone? IC looks like this. So these pins are called as port list. These pins are called as port list. Okay? Understood? Yeah. So here we have mentioned what? Sum comma carry and now semicolon. Here you have to mention end module, and between this you have to write what? What is the line? Define direction of signal. Define the direction of signal. So here we have mentioned four signal name. How do you know that these signals which is output and which is input? How do you know? So you have to mention input. What is input here?
A, B.
Comma B semicolon. Here we have to mention output.
Sam
What is
and
output?
Sam and
Sum comma carry is output. Okay. Define the direction. What is the next step? Instantiate the primitives. Means you are designing the half header. So what will be the structure of half header? What will be the structure of half header? Can you tell me what will be the structure of half header?
Sam is equal to
Yeah. Basically, sum means
A
sum will
exit
be, yeah, there will be the one XOR gate and one AND gate,
and
right?
gate.
We have, we have required two gates. One will be XOR gate and another will be
And
AND gate, right guys? So XOR gate, in XOR gates there are going two inputs and one output. Output will be sum and input will be AB, right? Right now? So here we have to call the here we have to call the XOR. XOR we have predefined. I have mentioned here. Yes. Right now? Sorry. XOR, not XOR. Here also. XOR. XOR. Right? XOR. And here you can see like in any design, in any circuit, there can be multiple XOR gate also.
yes,
Right now. So what we have to do, just you have to give here tag name something. Tag name. Suppose here we are giving G1 means gate 1. Okay. XOR tag name is called as instantiate name, and first of all we have to write the output then input. So what is the output of XOR gate?
sum,
Sum, comma input.
AB,
Same thing. Can you tell me for the AND gate? And
and Z.
G2
Carry,
what? Carry.
AB.
Nice. So this is the your half adder design. Okay guys, so can you see the structure, how it's going to design? Just let me show on the Xilinx, but we will not use Xilinx here, but just I am showing you because you will get clearly the picture in Xilinx software. Anshul, do you have Xilinx software?
No, sir.
No, sir.
I have Vivado. I have Vivado.
Okay. In
I-
Vivado also you can see the structure, right?
Yes.
So can I send you this code? Can you show here?
Yeah. Let me open it first.
Yeah, please open. If anyone have any doubt, please let me know. In this point, Aditi, are you able to understand?
Yes, sir. But I don't have Xilinx or Vivado.
Don't worry. Just I am giving you some demo, how it will looks like. Right? You don't have to work on Xilinx or Vivado. Just in Xilinx or Vivado, you can see the structure of structural modeling. Okay, and for behavior and data flow modeling, you will not able to see on Xilinx also. Right? Time being, you can open the tools, Abhishek.
Yeah, sir. It's taking bit time.
Yeah, not an issue. Just I am now explaining the. So this is the design part, right? This is the design part. So another thing, so we have to write the code for the verification purpose. Okay. Okay, everyone.
Yes.
So verification is very important part. Actually, it's called as test bench. Test bench. What is test bench? What is test bench? Test bench we are using to functional verify the functionality of digital design. Okay, What is test bench? Basically, test bench we are using to verify the functionality of the digital design. Means simple word, you can see that you have a mobile, right? Everyone is using mobile, right, Nada? So in every in your mobile there is lots of functionalities, right now there is lots of functionality, and even maybe you are using mobile 2 years 3 years, right?
Sir,
But
your voice is not coming properly.
hello, am I audible for everyone?
No, sir.
Everyone is facing problem.
Others?
No, sir, I'm not facing problem.
Who is facing problem? Aditi,
Yes, sir.
do you have any internet issues?
No.
Maybe there will be, means voice is breaking, or voice is slow, something.
Voice is breaking.
Voice is breaking, so maybe there will be internet issues at your home.
Okay, sir. Okay, sir. Now it's coming.
Now coming, okay. So test bench is used for the verify the functionality of the design. So just take an example for your mobile. Lots of features are there which you have not used till now, right?
Yes.
Lots of features. So by manually it's not possible to verify a complex circuit, complex system. So what we are doing, same thing we are using by code, doing by code. And another things, this is not a software testing. Okay, don't relate it like designer is software developer and verification engineer is a software tester. Don't think like that. If you are a verification engineer, so definitely you should have knowledge of design, then only you can become a verification engineer in VLSI domain. Okay guys, keep in your mind these things. Don't compare by software. Okay, and here another things, why verification role is too much important. Because see here, you have developed a software. Okay, you have developed a software, and what we are doing here, just opening the calculator. This is a software, right? Calculator. What we are doing, 8 plus 2, we are getting 10. It's correct. Okay, but sometimes multiple value we have given. Here we have given 42 plus 1. So instead of 43, suppose we are getting here 40 or 41. It means what? There is a bug of in software, right now? There is bug in software. If you are getting here 41, it means bug, na?
Yes.
You are not getting functionality correct. It means a software engineer what will do? They will do something, changes in their code, and you will get correct functionality, and you can update your software according to that, right? So is there any types of problem? No, right now. But in case of hardware, just think like that, there is your mobile and some features in your mobile is not working correctly. So what will happen? Is it possible to correct it easily? No. Company has to get the return back your mobile, and definitely they have to destroy that mobile only. There is no another options, right? Because in your mobile there is very small transistors which is made by using code, by using VLSI technology, so they can't change any capacitor or resistance, anything. Am I right? what they will do, they have to destroy. It means too much losses of company, right? So before converting this design to the hardware form, they have to verify by using only code. This code only they have to verify that this code's functionality is correct or not. To verify this code's functionality, we are writing same code, okay, in like a test bench to verify this code. Okay, guys. But nowadays no one is using Verilog based test bench because you know, we are writing system Verilog and UVM based test benches there. So we have to create another model for this there. You will learn these things, don't worry. Just we are writing a simple test bench by using Verilog to verify this functionality. Okay, got it? Got it, guys? Yeah. So how will you write? Same thing. Write a module. Module name anything you can give. TV underscore HA. There should be no any port list. Okay. There should be no any port list. Again, you have to write here in the module. Here we have to write every inputs. Whatever the inputs you can take as a reg. So reg A comma B. Every output you should take as a wire. Sum comma carry. Okay, guys. What another things you have to call this design so you can verify this design. Just call this design. How will you call this design? Half adder. Half underscore adder. Your design name is half underscore adder. Same instance name you have to give here HA. Like here you have given G1, right? Another things, you don't have to mention here like output first and input last. Which manner you have to take? Like here, see here in this port list in design, A is first. So whatever you will write here, it will automatically connect with B. A. Okay. If you are writing here B, it means B will connect with A. Okay. Everyone getting my point? Everyone getting my point or not?
Sir, why we written here REGAB?
Basically reg and wire is data type. Okay, so I'll explain you these things. Okay, so time will just use this like this. Every input should be as a reg type and every output should be as wire type. So just remember this point. Okay, I'll explain you later.
Previously, we have written input and output.
Yes, basically in this is the design. Design means just like a IC. Okay, design means just like a IC. That's why we have given the direction for this input and output. Test bench is looks like this. Test bench should be like this. This is the test bench. Here you called your design, and there should be also some pins. Okay, there should be like a pin, and this is connected with output. So we can read here what is the value we are getting, and this point is connected with input. Okay, so here we have taken some storage element, means reg is storage type data.
Registers.
Reg is storage type, and we have connected with this. In this bucket, suppose you are giving here 0, so this value it's getting 0. Here suppose we are giving 1, so our design is getting 1 from here. Okay, and whatever value you are getting 1 0 everything, so according to that here you will get the output, and here no need to store. Every time here this is connected, so continuously value you will get here. You have to read the value here only, right? So we are taking wire. wire is not storage, just simple like a wire. It will not store anything. Whatever value you are providing here, just you have connected with battery, it means here you will get the current. If you are disconnect with battery, so here will not get current, right? Understood? Aditi?
Yes, sir.
So every input as range time. This is the comment line, right? Here by using double slash we are commenting the line. Every output as void. Okay. Here we have called our design. So understood? Whatever you are writing here, suppose if you want to change the name here, instead of AB you can write P and Q. If you are writing here first P, so P will automatically connected with A. Got my point? This is called as positional mapping. This is called as positional mapping. Understood? Everyone understood? Yeah. So you have created this types of structure here. Now what is the role here? You have to provide some inputs, so you will observe based on output based on the input, right? So how will you provide the inputs? There is also something is added here by using initial block, initial begin end. Why you are using begin end? Suppose if you are writing multiple lines in initial block, so you have to write begin end. If you will not write begin end, it means only one line will consider in initial block. Understood? Everyone understood?
No, sir.
Not understood? So basically if you are providing anything, so you have to write in initial block. Any inputs you have to provide it in initial block. Just see here. Suppose here we have written here what? A equal to 0, B equal to 0. How many lines this is? Can you tell me? Can you tell me how many lines?